energy transfer within the climate system. Earth is unevenly heated by the sun because, number one, the sun's radiation reaches the Earth's surface with different intensities at different latitudes. So it heats up the equator more intensely than it does the poles. Water and land absorb energy at different rates. So we saw that in the lab that we did, that the water didn't heat up as quickly as the stones and the sand did. So if the sun beats down on an ocean, it'll heat it up less than if it was striking land. The climate system transports thermal energy from areas that have more energy to areas that have less energy. Most of this thermal energy circulation takes place in the atmosphere and the hydrosphere. So in the atmosphere, let's look at how that happens. So it's this thing called convection current. And I'm going to show you a quick little demonstration video on that. What I'm trying to demonstrate here is something called convection currents. So we have this apparatus here where this is just glass, so there's no wind coming in and out. And on the one side, you see a candle. On the other side, there's nothing. Above the candle is a chimney. So if I put a piece of incense on top of the chimney, what we see is that the smoke just goes up. It's not producing very much smoke. Can you get a little closer to it? And you can see the smoke going up. And then when we go to the other side, what we see is the smoke actually sucks down. You can see it going down the chimney. So why this is happening is on this side, okay, we have warm air, and it's pushing up. Warm air rises, and there's smoke going up. You can almost see it. And then on the other side, well, there's no warm air, it's cold air. So cold air sucks down. And what starts to happen is cold air goes down, and it's hard to see through the glass, but it comes across. There's a little bit coming to the candle, and then it comes back up this chimney. So convection is just warm air rising and cold air sinking. So when we look on a global perspective, what we see is the movement of warm and cold air creates circular currents called convection currents. So on the grand scheme of things, the sun beats down at the equator, heats that air, it rises, moves to the north. As it moves up, it cools down, and then it comes right back, cool air to the center, heats up again, and keeps going around and around. Convection currents are one of the main ways that energy is transported in the atmosphere. Earth has permanent bands of high and low pressures, so there are prevailing winds that blow in the same direction almost all the time. So prevailing winds, okay, they basically move warm air and warm water from the equator towards the poles. So I just want to look at two pictures here. So convection basically means, okay, the rising of warm air. As it rises, it starts to cool, it sinks, okay, sinks more because it's falling, and then all of a sudden gets heated again and rises. So it's just a circular thing that goes around and around and around. And if we see it on a global scale, well, what's happening is the sun beats down here at the equator. That warm air rises. As it rises and moves towards the North Pole, same thing happens towards the South Pole. It cools, and it comes down, gets heated, and it goes around and around. And we have these circular convection currents all the way around the Earth. So not only does air do this, but water does this as well. So cold, dense ocean water at the poles sinks to the ocean floor. Warmer surface water from the equator then flows to the poles to take its place, and it keeps cycling. So then once that warm surface water gets to the poles, it cools down, it sinks, and then again replaced by warm air from the equator again. This process is called thermal haline. So thermal means heat, haline means salt, meaning salt water. Okay, circulation of the oceans, because the oceans are salt water. Ocean currents around the globe slowly move water and thermal energy it carries from the equator to the poles. And this is just a neat diagram of the Earth's thermal ocean currents. So what we see is when it comes from the center of the equator, okay, and goes up, it's warm. If it's coming down, it's blue, it's cold, and then eventually gets warm and travels again. So these have been mapped out by satellites, by people, and plotted on a map for you to see. And we can see that if you're in an area that's constantly receiving cold ocean currents, okay, you're going to have cold weather. Whereas over here in the Azores, where my family's from, they constantly see that warm ocean current warming them up.